Am I audible now?
Yes, sir.
There was some technical problem, so that uh, the connection was restored. So anyway, so uh, what we are discussing, that by improving the instruction sets, by improving the architecture of the microprocessor or the microcontroller, the complexity of the performance, complexity of the application has been reduced. So it is called the reduced instruction set computers. So obviously, whenever a large number of instruction set is used, then it will be called the complex instruction set computers, or CISC processors. And whenever the number of instructions were reduced, then it will be called reduced instruction set computers, or RISC. Clear? So by going forward, the architecture first, will be just summarizing the microprocessor. What was in the microprocessor? That microprocessor is having a central processing unit. Okay, so this central processing unit, or in short, there is this called CPU. This includes a computer. uh, this contains inside the computer, and it includes this central processing unit, includes the arithmetic and logical unit, ALU, a program counter, and a stack pointer. Okay, these three things are mandatory, and in addition, for temporary data storage, some register are there, a clock timing circuit is there, and interrupt circuit is there. So the clock timing circuit is nothing but to drive the chip, but drive the processor. Okay, now let me ask you the same question that I asked in the previous semester also. Why the name is microprocessor? Why not kilo processor or milli processor? Why micro? Why the name is micro? Can you tell me, anyone?
So because the execution time is in microseconds.
Can you please repeat once, because the volume was so low?
So because the execution time of is in microseconds.
Very good. So this was the very basic question. So that can be asked in your interviews also. And as in the earlier semester, I have told you that this kind of, this particular subject is useful for the this microprocessor. This is very much essential for the Department of Computer Science, Electrical and EC, because, and as you know, this computer science engineering is some IT or computer, this kind of, software companies focused on this particular CSE department students, and core company focus on electrical students. So this is the advantage of EC department, this that the EC department can belong to software as well as the the core companies. Okay, so this is the subject that if you are expert of microprocessor and microcontroller, then you will be having a two subjects load will be reduced in case of campus interviews. Okay, so coming back to the subject, so this ALU, that nothing, this is nothing but this performs some arithmetic operations. This performs some logical operations like AND, OR, NAND, NOR, this kind of things, and a stack pointer. What is the function of stack pointer? Uh, can you remember the call and jump instructions in microprocessor or in microcontroller also? Can you remember? Yes or no? Okay, this microprocessor is having a stack pointer. This stack pointer is used for the uh, jump operation or call operation that has been used while performing a programming. Okay, and this program counter, what it does, this program counter stores the value. Store the particular next instruction to be executed. That address is to be stored into the program counter. Okay, some working registers are there. Likewise, in 8085 there was accumulator, B register, C register, D, E. These registers are available, and HL. These registers were available. Okay, so these particular registers were used for the temporary data storage, and clock timing circuit and interrupt circuits are there. So interrupt circuits are nothing but the external, it can be external or internal. Okay, so this internal thing, this particular internal interrupts means while performing an operation, any operation, that arithmetic operation or logical operation, if the program output is overflowed, then this particular interrupt has been generated internally. Okay, and when external interrupt comes, the external interrupt comes only when the externally some activities are going on, like if a timer circuit is time counting some particular time. After the overflow of timing operation, then it will send uh, a signal to the microprocessor that my execution, my task is over. Is that clear? Just like that, I'm telling something now in a lecture. I'm telling something, and you're listening. But after a while, someone of you, or multiple times, multiple students can raise that, sir, I have a question. Sir, I have a question. Suppose three students have a questions. Okay, so these three are interrupts. Okay, and whenever I am telling that, okay, student number one, student number two, and student number three, I have given a numbering, so that I need to take his or her question, that student one question, so his or her priority is highest. I'll be addressing the student one question, then student three, then student two. Likewise, I can set the priority to take the question. So there are some priorities in case of interrupts. So we'll be discussing again in the later classes. So there are some uh, criterias to develop a computer. Okay, so this mandatory thing is RAM and ROM. Okay, that random access memory and read-only memory, these two things are very much essential for designing a computer. In addition, there are parallel and serial input output lines should be there, because we can use a number of input and output devices with a computer, right? So in earlier computers we do use some floppy disks. Okay, nowadays floppy disk has been blown away, and there are. So here, uh, just two examples are given, just like a hard disk drive and IO peripherals have been given as keyboard and CRT displays. So CRT, apart from keyboard, there are mouse, there are some pen drives, flash drives that are used for the storage purpose. And in case of output device, the display, apart from the display, there are printers, there are scanners, there are some USB lights, some charging options. Okay, there are a number of activities can be done by using a digital computer only. Okay, but while in the going to the internal organization of the microprocessor, or the internal construction of the computer, then we can clearly see that CPU can read and write, okay, with the RAM and ROM. So here this RAM and ROM, along with these two, there are printer, optical discs, monitor and keyboard. So some of them are input device, some of them are output device. Like this keyboard and disk are some input device, and printer and monitor are output device. So RAM is very necessary. Not necessary. This is very important part of the of a digital computer. As you know, everybody of you are using some smartphones, and there are some tendency to use a big RAM phones, big internal storage phones. So what is the necessity? And usually we have seen that the smartphones having a higher RAM and higher storage capacity uh, is a advantageous, that because their speeds are better than the lower RAM and lower storage capacity phones. So what is the, whenever some program is executed, then this program has been run onto a RAM, okay, and whenever the program is stopped, then the program has been removed from the RAM. Clear? So this random access memory is the actual memory of the computer, okay, and whatever we have used, that storage devices like hard disk, like optical drives, like CD and DVDs, pen drives, these are nothing but the dump drives. We are dumping some data into those drives, okay. These are storage devices, not memory devices. So this memory, whenever this memory uh, length is greater, then multiple programs can run. Just for example, agar if there is a program length of 10 kilobytes, then 1 MB of RAM can store how many programs? And so, say this 10 KB programs can be stored into a 10 MB RAM, 100 MB RAM, or 1000 MB RAM. So what is more advantageous? Obviously the higher ones. Clear? So there are some advantages of higher RAM devices over the lower RAM and lower storage capacity devices, okay. So here comes the microcontroller. That microcontroller, which is also known as a true computer on a single chip, it has a CPU which contains ALU, program counter, stack pointer, registers. So in addition, with a fixed amount of RAM, ROM and input-output ports, including the serial communication and timer, all are embedded together on a single chip, just unlike the microprocessor. So microprocessor will be having some internal, internal ALU, but there are no RAM and ROM is included with the microprocessor. But in microcontroller, as this is the dedicated purpose device, so ALU, program counter, stack pointer, register, that is associated and added with the RAM, ROM and IO ports, okay. And some of the IO ports will see that some of the IO ports can be used for the serial and parallel communication, okay. For whatever we will be focusing on 889C51 family microcontrollers, okay. And as we have discussed earlier also, that some real world data, that whatever I am talking, whatever I am telling you, this is nothing but the analog data. Every real world data is analog data, okay, but we cannot process them or store them. What we have to do to store them? We need to convert to its equivalent digital form, okay. So this digital form, that includes from real world data, we have to use a certain thing that converts the analog data into its equivalent digital data. So, and again, after processing or after storing from the storage things or the computer things, we need to get the real world data. Otherwise we cannot understand, the human beings cannot understand the digital data, because when we are talking, then we are not telling zeros and ones, the series of zeros and ones we cannot talk. Okay, and if you are telling that 0 1 1 0 0 0 1, will you understand? No, I need to understand. I mean, I need to tell in a language that you understood, that you understand. Clear? So for this, the real world data cannot be processed and stored. So, and similarly, the digital data cannot be used in the real world. So some conversion of analog to digital and digital to analog should be there. But in case of 89C51 microcontrollers, they don't have any ADC or DAC embedded on chip. They need to be connected externally. But there are some advanced microcontrollers that includes the analog to digital converters. Okay, so there are some, I'm just stopping the share, and you people are requested to scan the QR code now. So this QR code is very much necessary with the for the attendance. So every people are requested to scan the QR code to get the attendance. Are you having any problem? So everyone have taken their attendance, and I'm stopping this QR code. Okay. Okay. So getting back to the subject, that there are some pictorial.
Sir, it is showing invalid login, sir.
Your name?
Hello.
Your name?
Raj Lagori.
Okay. For Raj Laguri, Shalini Priya, and MD Ehtasham, I'll be taking your attendance later on, because
Yes, sir.
there are some issues with your login ID, I think. Okay. Uh,
Yes, sir.
yeah, yeah. Okay. There are some differences, the pictorial differences has been shown into this particular diagram, that their CPU is externally connected with the RAM, ROM, input output ports, timer, and serial communication ports. But in case of microcontroller, there are CPU, RAM, ROM, input output ports, timer, and serial communication port that are combined together. Okay, that all are connected on chip, because this, as we have discussed, that microcontroller is a dedicated purpose device, while this microprocessor is a general purpose device. General purpose means it can perform any kind of job and multiple jobs, multiple processes parallelly. Okay, so that this is called the general purpose system. Okay, so this microcontroller is sorry, this my difference between the microprocessor and the microcontroller, as we have already discussed, that microprocessor contains no RAM, no ROM, or input output ports, or serial communication ports, or a timer, or DSC, ADC, counter. These are not included on chip, but the microcontroller is having the CPU in addition to the on chip RAM, ROM, timer, counter, IO ports. These kind of all are included on chip, and the addition of RAM, ROM, IO ports to this microprocessor unit makes the total system bulkier and expensive also. But in case of microcontroller, it will cost hardly 40 to 50 rupees, okay, for our daily purpose use. But in case of microprocessor, it will cost 800 to 1000 rupees also, because we need to install other external peripherals uh, in an extra manner, and we need to program them also. Okay, but here we need not to get into the interfacing, unless we need some external RAM to be installed, external timer is to be installed, we need not to program them. But as this is the dedicated purpose device, so we can use the internal RAMs and internal ROMs in an expensive way. Okay, so and this is related to the second point. So this microprocessor connected to the second point, that microprocessor systems can use a small cannot use a small circuitry, because of the presence of RAM, ROM, and external peripheral devices, not peripheral devices, RAM, ROM, and IO port system, timers, DMA controllers that needs to be connected externally. So the overall circuitry is complex. Okay, so small circuitry cannot be made, but in case of microcontroller, a very small circuitry can be made. Okay, so and obviously, as the microprocessor is having multiple jobs can be performed in a parallelly multiple jobs can be performed, so that this have the versatility of the RAM, ROM, and IO ports, okay, by using. So but there are some limitations on the microcontroller chips, because it is the general, no, it is not general purpose device, it is a dedicated purpose device. Okay, okay, so this is the last point, that the versatility of the microcontroller is very less, because it is the dedicated purpose device, so we cannot use some for parallel purpose use. Okay, so we are stopping our today's class. Okay, so everyone has given their attendance. Thank you so much.